The purpose of this research was to study the impact response of different materials for sports mouthguards. Up to this moment, there is no guideline regarding the materials to produce mouthguards. The most used one is ethylene-vinyl acetate. Studies indicate that laminating EVA sheets with rigid components could increase the protection capacities of the mouthguards. On the other hand, other studies suggest that only replacement of the material within its structure can increase energy absorption. Therefore, this work aims to evaluate the impact response of 4 different foils when compared to a 4 mm thickness EVA sheet. Five different materials were subjected to impact tests with energies of 1.72 joules, 2.85 joules, and 4.40 joules. In this context was considered the following materials: EVA foils of 4 mm thickness, EVA foils with an EVA foam core, EVA foils with an acetate core, foils of Erkoloc-pro, and foils of Ortho IBT resin. Comparisons between the materials were made by qualitative analysis of the average energy time and load displacement curves, as well as by comparison of the peak load maximum displacement, contact time, and absorbed energy, using the Kruskal-Wallis test. It was possible to conclude that statistically significant differences were found in the energy absorbed. EVA soft foils presented the least peak load and the highest contact time, which means the higher energy absorption by the foil. In this image, we can see the impact damage and observe the delamination in EVA foils with an acetate core, severe puncture damage in Erkoloc-pro, and cohesive fracture of the foil in resin IBT. We came to the conclusion that laminated foils with a soft core are a good option to produce mouthguards, while EVA foils with an acetate core, foils of IBT resin, and rigid and thinner materials were declared unsuitable.